The random variables x is such that x follows binomial distribution with 25 and p, and variance is 5.75. Find the possible values of p. Based on this formula, we can set up variance of x equals n is 25 times p, then times 1 minus p. Variance of x is 5.75 equals 25p times 1 minus p. Since this is a quadratic function, we will get equal to 0, then use the polyroots. Let's go to calculator, then control menu. I couldn't find the polyroots, which means I have to do distributive property before I use the polyroots. So work this out. 25p minus 25p squared minus 5.75. Let's use the polyroots again. Control menu. Enter, enter, enter. P equals 0.359 or P equals 0.641. From here, find the possible values of P means there are more than one value. Let's go to B. The random variable y is such that y equals 1 minus 2x. Find variance y. Variance y equals variance 1 minus 2x. We will use linear transformation of a single random variable. This formula equals variance negative 2x plus 1. So we get negative 2 squared variance x equals 4 times 5.75 equals 23. Let's go to question 6. The random variable x is normally distributed with a mean 10 and a standard deviation 2. Find the probability that x is more than 1.5 standard deviations above the mean, which means we need to get a probability of x greater than 1.5 times sigma plus mean equals probability of x greater than 1.5 times 2 plus 10 is 13. We got to use norm CDF. Lower bound is 13, upper bound is a positive infinity. 10, 2. Remember, for continuous random variables, this x is all real numbers, and the area under the curve is the probability. That's the reason probability of x less than c equals the probability of x less than or equal to c. Let's go to calculator. Go to menu. 5, 5, 2. Lower bound is 13. Upper bound, you have to use this pi. Enter. Mu is 10. Standard deviation is 2. Enter. 0.0668 is the solution. The probability that x is more than k standard deviations above the mean is 0.1. Find the value of k. Based on this information, probability of x greater than k times sigma plus mu equals 0.1. Probability of x greater than 2k plus 10 equals 0.1. Since we are looking for specific data, we got to use inverse normal. We know area always equals probability of x less than c. So we need to figure out probability of x less than 2k plus 10 equals 1 minus 0.1 equals 0.9. Then we go to inverse norm. 0.9, 10, 2. So 2k plus 10 equals inverse norm 0.9, 10, 2. Go to menu 5, 5, 3, 0.9. Mu is 10, sigma is 2, enter, enter. 12.5631. Then by solver, we can figure out this k. 2k plus 10 equals, pull this down, then control menu, enter, enter, enter. K equals 1.28.